Okay, we're in the section 9, and this is the materials for exercise 9. Again, my name is Ron Bannon, and you're looking at a draft version of my my Webster Wells rewrite. All right, so each section looks the same to me. I mean, there's contents, there's examples, there's exercises. I'm not going to read it to you. All right, I'm not going to read the contents. You should read through the contents. There's really not much material being presented. I'll scroll through it. But really what I'm doing over here is doing the examples. And it's not for everyone to watch, but for some students, they like watching someone do examples. It helps them. If it doesn't help you, don't watch them. Read and try to struggle through it on your own. And that's so important. You're really at your own, you're making your own learning journey here. All right. Again, for people that need to reach out to me, my name is Ron Bannon. My email address is Bannon. That's B, the @ symbol, NNON.US. Again, this document is being prepared for the prison mathematics project. They have access to the PDFs. My gut feeling is not published yet, but my gut feeling is at some point I have to publish it, and I'll most likely publish it as a PDF, and I'll probably publish it through Dropbox. All right, that'll take time though. All right, that'll take time. I'm still writing the document, believe it or not. So let's just scroll through it. I always say you really should read the book. Now this is all about factoring. Someone says, "What's factoring?" It's writing things as products, right? It's something that we do, and there's techniques for it. And I gotta be honest with you, the best technique is, I always say, give it a shot. If they say you can factor it, there's a really good chance you can factor it. So I'll go through what I want you to look for, and certainly the way I speak through the problems may be different than the way Wells would speak through it. Now, what do I notice? There's two. This is number one we're trying. I notice there's two terms, and the first thing I want to do is there a common factor between those two terms? Now, when I say that, I'm actually looking for what's called the greatest. That's G, common factor. I'm looking for a GCF. So the way I like to do it, I like to look at the numbers first, and if you see 14 and 35, I'm kind of by inspection, I'm saying, oh, gee, it has to be 7, because 7 times 2 is 14, and 7 times 5 is 35. So I'll put this over here. Now, the other factor I'm looking at of these two terms is the factor A, and the greatest number of factors they have in common is just one simple A. Now, if I look at the B's, the first term has B4 in it, that's 4 factors. The second term has B squared in it, 2 factors. So I'm saying they have 2 factors in common. This is GCF factoring. What are you left with? 2. Someone says, why is that? 2 times 7 is 14. I have the A, but I need another B squared. Put that down. Minus 7 times what would be 35? 5. And you need A cubed, so I need A squared now. That would give me A cubed. And let's see, we got the B squared. You don't need that. That's what we want you to do. We want you to factor it and look at the key, see if you come up with it. All right? Now, I want to be honest with you, though. You can continue to factor this. You can continue. We're not there yet. But that can be continued to be factored. All right? Okay, let's look at the next guy. And again, you may look and say, this is really complicated, but I still have these two terms. This term and that term. And then the big question comes, do those two terms have a factor in common? And they do. The factor they have in common is 2m plus 3. That's what they have in common. They both have it. This has it, and this has it. What's left over? X squared plus y cubed. I'll put a box in it. Again, my gut feeling is you should look at the answer key to make sure you're looking at that. I don't think I did that over here. Yeah, I did. I did okay there. Let's look at this one over here. This one looks really strange to me. And I want to claim to you that a lot of students, what they do when they see something strange is they do something that, I'm not going to say is wrong, they just multiply it out. And I'll write this down for you. So this would be AM minus BM. And then what do you get? You get plus BN minus AN. And by the way, I'm not saying that gets you anywhere, but you know what? If that's what you did, that's what you did. Now, you may want to rearrange these things, and there's many ways to do it. I'm going to put this down. By the way, you say, oh, your key, you did something different. I'm not saying I didn't. I'm just looking around for something to do. And you should look around for something to do too, including you're going up a dead end. But I'll write this down, AM minus AN. Now, so what are you doing over there? I'm kind of moving things around. Then I'm going to write down BN minus BN. All right? Now, there's 4 terms there. What am I going to do? I'm going to look for common factors. But there are no common factors, except if I divide into 2 parts. So if I divide into this part and this part, I'd have common factors to each of those parts. So what's common factor to the first part? A. And you get M minus N. Right? Hope that wasn't too bad. Second part, B, N minus M. Well, I'm in the same conundrum, and I'll tell you why. I'm still not seeing any factors common to the 2. So although I tried something, it really wasn't successful. What I recommend you do is erase it. But I'll be honest with you, going back to the original problem, I want to look at it, and I'm starting to think to myself, maybe there is something about these 2. So if I look at these 2 terms over here, it's a term, and this is a term, and I really notice they both have a factor that's somewhat related. I see A minus B and B minus A. So what I'm going to do is just simply rewrite it so it looks the same. So the first term is A minus B, M, and in the second term, I'm going to factor out a minus 1. And what would you get over there? You would get A minus B. Hope I didn't go too fast with that, N. All right? What am I noticing now? I have 2 terms that there is a common factor, and it's A minus B. What are you left off with? M minus 1N, which is just N. And again, if you want to multiply that out, you can. I want to claim over here there is an answer over here for you. A minus B, M minus N. They're the 2 factors. All right, let's look at this one over here. And again, I'm looking at it, and you might think X minus Y, X plus Y is what we're looking at. It's not what we're looking at. There's no way to get those to be the same. You might say, oh, factor out minus 1. It's not going to happen. All right, let's write this over here. And do I see anything common between those 2 terms? And I do. I see the letter A. Now, I know what somebody's going to say. They say, your work looks different. I'm just going to see A. What do I see next? 5x minus y minus 3x plus y. And I got to be perfectly honest, it is factored. That's a factorization of the problem. It just doesn't look right to me, though. Let's go through it. 5x minus 5y minus 3x minus 3y. Again, that still doesn't look right to me. I'll keep going. A, 5x minus 3x is 2x. Minus 5y minus 3y is minus 8y. Now, once I do that, I start to realize there's another factor that's common, and that's a 2. I'll pull it out. So 2a, I pulled the 2 out. What do you get? X minus 4y. Now, I realize what Simpson's going to do. Say, oh, that looks different. It does. This work over here looks different. But don't think any one work is better than the other. Work is what's going to be important, and you're able to do the work. But the answers are always going to be the same. All right, let's take a look at the next one. The next one says factor. And I'm looking at this over here, and there's 4 terms, right? 1, 2, 3, 4. There's 4 terms. What I would recommend you do, and I'm not going to say it's going to work, is just simply look at the first 2 terms and the last 2 terms and see if you can factor those. So, for example, in the first 2 terms, what do you get? What's the factor common there? Just an A, right? And we're left off with B minus Y. Now, if you looked at the last 2 terms, I'll put the plus sign down. What's common there? If I saw it, what's the common factor there? Would just be an X, right? And we're left off with B minus Y. Now, what do I notice? I have 2 terms, and those 2 terms now have a factor in common, and the factor they have in common is B minus Y. What's left? A plus X. If you like, you can check it by multiplying it out, but what am I going to do? Just look at the answer key to make sure I'm staring at that. Now, I realize what some students may say, oh, they're in different orders. Multiplication is commutative. You can write it in any order you like. So B minus Y, being first, or B minus Y second really doesn't much matter, and A plus X is certainly a factor of it. So it looks pretty good. We did this good. It's the same thing as written in the answer key. Let's keep going. Let's do this one over here. And again, I'm going to say there's 4 terms, factoring by grouping. First 2 terms, I'm looking at it. And I'm going to say A squared And we left off with a plus 2. All right, let me just go back over, my recommendation. Not that it always works. Sorry about that. I get my eraser out. I'm going to say it can't hurt to use the minus sign in the middle. Not that it's going to work. I just want to give it a try. So minus, and what's common between those two terms of number 3? 3a, right? Minus 3a. And then what are you going to get over there? Looks like you can get plus 2. Let's see if that works. You would get minus 3a and you would get minus 6. What do I notice? Those two terms have a factor in common, and that factor is a plus 2. What are you left off with? A squared from the first term and minus 3 from the second term. My encouragement to you is this. Look at the answer key, and you're seeing it. You're seeing the a plus 2, and you're seeing the a squared minus 3. All right? That pretty much covers that section out. But when I say it covers a section, doesn't mean it covers it for you. You have to read that section. I would pay careful attention to what they're talking about factorization. Make sure you can do the examples, and then get busy with the exercises. You want to be able to do that, all right? You want to do that, and on your own, by the way. Do I provide some work and some answer? Of course I do, all right? But again, it's not a lot of work, but there is some work, and there's certainly answers over there, all right? So there's some questions over there. Again, my encouragement is to try. Just try. Right? Again, related stage code. Let me just remind you, it's a computer algebra system. That's CAS. Why do I like it so much? It's free. It's used all over the world. Go to the website. You can download it as an application, or you can use the interactive web-based application. What do we encourage you to do? Type this stuff in over here. Let me remind you, reset means give me a clean sheet of paper. When I defined A, B, C, M, and N as variables, I'm just telling the computer, hey, they're variables. Then what I do, I factored something, and it gives me the factorization of it. Now, again, you may look back over the notes for the problem. It can't hurt to look. We're giving you these things for a reason. We want you to see the connection between how a computer does something, basically spitting back an answer, and the way you did it, and how much more difficult it is to do things by hand. What are you learning by hand, though? You're learning patterns, and that's what we're really looking forward to, getting patterns. So again, let me remind you, my name is Ron Bannon. I have an email address. Again, sometimes I'm overwhelmed with email and I won't answer you. But the bottom line is, just if it's really important, keep reaching out. All right? So that's Bannon, which is B as in boy, the @ symbol, NNON.US. Again, thank you for paying attention.